How does XPS allow for the analysis of various oxidation states within a material? What is the depth sensitivity of XPS when conducting surface analysis, and how deep can it typically detect? How does the depth range of 0.5 to 10 nanometers affect the type of material surfaces XPS can analyze? Why is XPS particularly sensitive to microsurface analysis? What limitations does XPS have in terms of the depth of material it can analyze effectively? How does XPS provide insight into the surface structure of materials, and how is this useful for material characterization? How can understanding these capabilities of XPS help in applying the technique to specific material analysis tasks? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How might the ability of XPS to detect all elements except H and He be an advantage in material characterization? How can XPS be used to investigate both the chemical composition and structural details of materials? What are the 5 main types of characteristic curves found in XPS spectra? What is the photoelectron line, and how is it characterized in the spectrum? Why does the photoelectron line have the highest intensity in the XPS spectrum? What is meant by the photoelectron line having the smallest peak width? How does the symmetry of the photoelectron line contribute to its identification in XPS spectra? How does each element in the sample correspond to a specific photoelectron line in the spectrum? What factors determine the position of the photoelectron line for each element in XPS? How does the intensity of the photoelectron line help in identifying the presence of an element in the material? How can the shape and symmetry of the photoelectron line be used to assess the quality of the XPS spectrum? Why is the photoelectron line considered an important feature when interpreting XPS spectra? How do photoelectron lines help in distinguishing between different elements in a complex sample? How can the photoelectron line be used to compare the concentrations of elements in a material? How does the XPS spectrum provide both qualitative and quantitative information through the analysis of these characteristic curves? Why is the photoelectron line considered a key feature in XPS analysis, and how does it affect the accuracy of elemental analysis? How does the understanding of these characteristic curves assist in interpreting and applying XPS in material characterization? What is the significance of the photoelectron line in XPS spectra? And why is it positioned at a specific place in the spectrum? How can the photoelectron line be used to qualitatively analyze the elemental species present in the material? How does the photoelectron line help in determining the valence states of elements in a sample? What is the Ocalo line in XPS, and how is it formed? How does the photoionization of an inner electron lead to the formation of a hole and an excited atom?